Okay, so let's look at exponential equations. Now, when we talk about exponential equations, of course, we're talking about equations that have the variable for which we're trying to solve in the exponent position. So, like this one, we have 2 to the x minus 3 equals 6. And here's the process. First of all, we want to isolate the exponent term. So that means I needed to add 3 to both sides in this case. So we've got 2 to the x equals 9. Now after we isolate, we want to log both sides. It doesn't matter really which log you use. I use natural log because at the end my answer is in terms of natural log, and that makes it so that I can go ahead and get a decimal approximation of the answer with my calculator, because the calculator doesn't have, for example, base 2, log base 2. At least the 84 doesn't. The Casio does, but not the 84. Now after you log, then you want to solve. And that just means, of course, the reason we log is so that we can bring that x out front. So you'll notice here I brought the x out front and then divide by 2, and you've got your solution. Any questions about that? Now let's look at this one. First thing you want to do is you want to add 7 to both sides. Okay. So here I go. I'm going to add 7, and you get 4 to the 2x plus 5 equals 11. Now, the next thing you do is take the natural log on both sides. And of course, the purpose for that was to bring the 2x plus 5 out front. So, I've got 2x plus 5, natural log of 4 equals natural log of 11. Now what? What do you do? Well, probably the easiest thing is to go ahead and divide out this natural log of 4. I mean, you could go ahead and distribute through and clear the parentheses, but that seems like a lot of extra work when you could just go ahead and divide it out like that. Okay, any questions? Now I subtract the 5, so now I'm just solving. You know, just going through the usual process of solving an equation. Multiply through by 1/2 and you're finished. X equals 1/2. Now is there any need to test this solution to make sure it works? That's right. We don't need to. But why? How do you know we don't need to test this solution? To make sure that we've got a defined exponential term up there. Well, remember the domain of an exponential function is all real numbers. So we can plug in any real number in and still get something defined. So in other words, with the natural law, or with logarithms, with a log function, we have to be sure that we don't try to take the log of anything that's 0 or under. But here, we can plug in any number, 0 or less, into an exponential function because of the domain. So whether or not, you know, plugging this in will give us something that's a real number is not even an issue here. Any questions about that? Okay, let's look at the next one then. Now, first of all, we want to isolate. Now, this one is a little bit different than some of those that we've looked at in the past in that you have a 2 being multiplied times the base. So you have to be careful. In your isolation, you're still going to add a 3 to both sides, first of all. That's right. You divide by 2. So there equals 10. Now you divide by 2. Okay, does everybody see that? In other words, you don't want to make the mistake and call this 6 to the 2x minus 5.
That doesn't work.
No, that wouldn't work. Remember your order of operations. Before you do multiplying, you're going to take care of exponents. That's right. 3 to the 2x minus 5 equals 5. Now you can go through and do your natural log. Okay. And the whole purpose there, so I could bring this 2x minus 5 out front. Okay. Any questions? Now what do you do next? What do you do next, Josh?
Then you put the natural log of 3 underneath, or you divide the natural log of 5 by the natural log of 3. So you keep the 2x.
That's perfect. So natural log of 5 divided by natural log of 3. Okay. Now you add 5. So let's go up here. Whoops. Okay. So now we add 5. 2x equals the natural log of 5 over natural log of 3 plus 5. Huh?
Can you or cancel the 5s out? Or no?
No, you can't cancel the 5s out.
Okay.
One of the things you've got to realize is when you see like a natural log of 5, that's not, don't think of that as a 5.
It's base 5 and then the other 5.
Well, you think of that as natural log of 5. The 5, in other words, you can't do arithmetic like the natural log of 5 times 3 is not the natural log of 15 or anything like that. It's the natural log of 5. That's not 5. See, something else.
And then we divide by 2.
Yeah, or multiply by 1/2. So here you go. X equals 1/2 natural log of 5 over natural log of 3 plus 5. And there's your result.
So we multiply by 1/2 and or divide by?
That's right. You can do either way. Either way you prefer. You don't have to. You don't have to do it the way that I did it, where you multiply by 1/2. You can go ahead and divide by 2 if you want.